So first of all, good news. My internet connection is back up, as it may look like. Do you guys hear? So that was exciting stuff. They fixed that this morning. Yeah, don't shovel through your internet line. It's bad for it. All right. So we've got a TA in our class now. It's week 11 or 12. I'm not really sure if spring break counts. We got a TA, so that's cool. And they will be helping go through all the grading and stuff like that. So stay tuned on that. I've been steadily working through all the different discussion sections and Space Invaders. If yours hasn't been graded yet, don't panic. We've got a TA coming in, so it'll help speed everything up. So it does take a long time because I have to play all of the Space Invaders. It takes a while. And a lot of people on the Space Invaders, their shots went sideways. So maybe we can talk about that on Friday, and do a next programming assignment starting on Friday. Okay. For now, though, we are going to talk. We're going to start talking about the nature of science, philosophy of science. This topic is, and you says you got a 0. If you did not submit the URL on Canvas like it asked you to, you got a 0. So just message it to me and I'll take a look. I'm not here to beat you guys up or anything. It's like, last time I had you guys do it on the studio, but this, like, as about a third of you guys saw, like, a lot of the projects just weren't showing on the studio. I think MIT didn't expect there to be a class with more than 80 people in it. And because Scratch is targeted more at a younger audience than college, but I think it works perfectly well as an introduction to programming. And so that was just kind of a mess with, like, a lot of the Scratch projects just not showing up because their website assumed that you would have 30 or 40. Like last time, right? We talked about framing, and so the Scratch people are like, we're making this for elementary school, middle school classes, so there's 30 people in it, and so they didn't maybe think that there could be 100 people in a class, and then those assumptions get baked into the website or the code or wherever those assumptions were made, and then the thing broke, right? Like, it just wouldn't load things in the studio past a point. I don't know. Okay. Can you give us an example of an algorithmic bias on the web? Yeah, the example that I gave you was from the movie Coded Bias. In fact, if you just watch this, somebody last time said that it was up on Netflix now. And so, oh, well, there's the whole movie right there. I don't know if it's legitimate or not, but it's worth a shot maybe. And so, for example, facial recognition doesn't work as well on people with dark skin. Another example would be cameras that do blink detection. It's like if they take your picture while your eyes are closed, it'll say, "Did you blink?" And that works reasonably well, except on Asian people, a lot of times it would say, "Did you blink?" when they were just not blinking. And you might be like, that's racist, but, like, one of the cameras that did that was Sony, and Sony is like a pretty major Japanese company, so I don't know. It's always dangerous to, like, try to guess intentionality and stuff like that. It's probably just, they had some sort of thing that measured, I don't know, eye height or something like that, and they just put in a number, and so those would be two easy examples. A third one was the policing, predictive policing thing. What's up, girl child? Look at that. Not bad at all. Some good engineering you did there, girl.
Cute box.
Yeah. And the parts were given to you, but you still did that build yourself. Very cool. All right. Close the door, girl, please. Thank you. So, you can't use my examples. right? So the three examples I've given you can't use. You got to find something else. Okay. But if you watch this documentary, it'll probably give you some ideas. Okay. All right. So we're going to be talking about Kuhn and the structure of scientific revolutions today, and then we'll get into the reproducibility crisis, which has a couple different names. Okay. We've already talked about censorship. Okay. So the topic that we're going to be talking about today falls under the notion of philosophy of science. Philosophy of science. Out of curiosity, have any of you guys taken a philosophy of science class? Like a class specifically on philosophy of science? I took it in grad school, and it was really interesting, actually. Philosophy in general, like I would recommend to anyone, because if you like this kind of critical thinking, like learning how to think kinds of things, philosophy is really good at it. It's really good at challenging your assumptions and kind of expanding your brain and thinking about different things. Socrates said, "The unexamined life is not worth living," right? Because most people just go through life just kind of inheriting their beliefs and biases from other people, and they don't really think about it. Does this hold up to scrutiny, right? So, yeah, philosophy in general, I enjoy. It really depends on the philosophy professor. Some classes could be pretty boring. Like just pretty, like you're taking the great questions of the universe, like, is there a God? And they just turn it into the most boring, like, thing possible. But if you got a good professor and they really have you, like, is there such a thing as free will? Like they'll present an argument, you're like, oh wow, we do have free will. And they present an argument for the other, you're like, oh wow, we don't have free will. And they're like, wait, both of these can't be true, and then you debate it with your friends and or write essays in class and things like that. And it's really amazing if you get the right professor for it. So yeah, highly recommend. This critical thinking class is in part based on my experience with philosophy. Okay, so scientific revolutions. So a lot of people think that science is sort of like a linear progression forward, right? Like as time progresses, more papers come out, scientific knowledge advances, old ideas that were bad are discarded, new ideas that are good are adopted, so on and so forth. However, it's not really that clean, right? So like if you look at the notion of false starts, like where like science will come up with an idea and people get really excited over it and they write thousands and thousands of papers on it, and then it doesn't lead anywhere, like string theory, which may still be true, right? It may still even be true, but like there's never been any experimental evidence for string theory, and there might not ever be, who knows. But back I don't know, 20 years ago, everyone wanted to be a string theorist and were writing papers on it. Never led anywhere, right? And some people still think it's true, and it may be true. Like that's the funny thing is, like, if you can't test it, like, I don't know, maybe it's true. Can't really know. So, but that's fine, because oftentimes you don't know something's false until you've kind of explored it, right? Like, maybe hydroxychloroquine, right? Like that was a big thing. A year ago, a French doctor published a paper saying hydroxychloroquine was good against COVID-19. And this turned into a political football because Trump touted it as a cure-all for COVID-19. Various states started stocking up on it. People were fighting over the hydroxychloroquine stocks, and it's a drug used in like treatment of malaria and some other things, if I recall correctly. And which I might not be, like a lot of these lectures I'm just doing off the top of my head. like last time I think I said Richard Dawkins went to a Catholic school when he went to an Anglican school. Completely different. He went to an Anglican middle and high school. So, not Catholic. And so people thought hydroxychloroquine was a cure-all for COVID-19. And then science studied it. Like, there was a preliminary study coming out of France, and then based on the results of the preliminary study, bigger sample size, randomized trials and things like that, and they found that hydroxychloroquine didn't have any effect on COVID-19. But then, the original author said, yes, but you're only giving hydroxychloroquine to people that are seriously sick. My study says that it works early on in the disease. And so there's this kind of back and forth, right? And it's not clean. Like states were literally stockpiling hydroxychloroquine as a result of this preliminary study. It's not like science lives in a bubble off by itself. You're gonna hear this message from me a lot, because I very firmly believe that when you do computer science, for example, you have to think about the social impact of your work. Am I helping the world? Am I harming the world? And like when you publish a scientific study on hydroxychloroquine, people go out there and buy it. My dad said if he got sick, he would drive down to Tijuana. He lives in San Diego, and buy hydroxychloroquine. And like, I don't know. Like that's a decision he made based on science, right? Or a paper in science. And so what's really frustrating is, like, scientific papers are supposed to be like 95% confident they're true. But if you look at like almost any question in health and medicine and things like that, what you will see is that there are papers, studies done supporting both sides. And you're just like, but I thought that was impossible. I thought we were supposed to be 95% confident that orange juice cures cancer. And then the people do a meta study, right? So they'll look at 11 studies of, does orange juice cause cancer? Does orange juice cure cancer? And they'll find that 7 of them say that orange juice causes cancer. 4 of them say orange juice cures cancer. 3 of them might be in the middle. I don't know. Right. And then the meta study will be like, yes, but even though there's more studies showing that orange juice causes cancer, the ones that show that it cures cancer are of better quality, but the ones that show no effect are of even better quality, but a smaller sample size. So in conclusion, right? And it's really frustrating. And science, you get evidence one way, you get evidence the other way, and people sit there and try to like look at it and like try and figure out what reality is, and it's really messy and it's really hard. And so we have to do the best we can based on the current state of the science. Like we don't have the benefit of living in the future and being able to look back on it and be like, oh well, obviously you should be drinking orange juice or not drinking orange juice. What you got, girl? Get your bird again? So, because we're living in the moment, right? We're living in a pandemic right now, and you personally have to make a decision, right? Are you going to get vaccinated? Yes or no? Are you going to take hydroxychloroquine? Yes or no? Are you going to take vitamin D supplements? Yes or no? And we don't know all the facts. We never do. But like when you're in the moment and science is still advancing, it's like, what do? Right? Because you're forced to make a decision, right? You're forced to make a decision. Are you going to get a vaccine or not, right? Are you going to take vitamin D or not? And the results are kind of like, well, there, for hydroxychloroquine, it looks like it probably doesn't do anything based on what these big studies have said, but the original author was cast out on those big studies. Vitamin D, there's been a lot of research on vitamin D with COVID-19. There's a strong correlation between low vitamin D levels and increased mortality from COVID-19. But correlation, stay with me, people. There's a strong correlation between low vitamin D levels and COVID mortality, but very good, very good. Correlation is not causation, right? And so it's kind of like when people get sick, their vitamin D levels drop. You know what I mean? And so, but then and I read a study on that, and they said, well, yeah, we can get people sick and see how much their vitamin D levels drop. You know, we can give them a different coronavirus, like a common cold coronavirus, and see that their vitamin D levels drop this much, but with coronavirus they drop this much. But, and then the other people say, well, yeah, but you know, the coronavirus, the COVID-19 people are more sick. And so there's this back and forth on it. And so nobody really knows right now, as best as I can tell. And I've actually spent hours on this issue. So clearly, I'm an expert. Dunning-Kruger effect, right? Dunning-Kruger effect. But seriously, like, it's kind of like one of the things, like, there's scientists on both sides, and some say it's just a correlation, some say it's causation. I can tell you that at my wife's hospital, as part of the treatment for COVID-19, they will empirically give you vitamin D, because why not, right? Like, it might work, and if your vitamin D levels are low, might as well supplement vitamin D. Like, you know, it's, you know, if you have a deficiency, you should supplement it. So, like, you know, it's not like, you know, there's really much of a downside to it. But like all of you have to decide: am I going to supplement vitamin D or not? Right? Do you know what your vitamin D levels are? You know, for one thing, and you know, are you going to supplement it because there's a pandemic going on? And so, you know, that's a decision that all of you have to make right now. You know, and you don't know unless any of you guys are like, you know, have knowledge that I don't, because you might very well. The world's a big, complicated place. You don't know that vitamin D actually will protect you from COVID-19 or not, but you can make that decision. So, how well could it be if vitamin D deficiencies messed you up worse with COVID? It's possible. It's possible. Because, you know, if people are indoors a lot, right now, and so, like, it's possible that vitamin D levels are dropping because people aren't going out as much. And then that could be making COVID-19 worse. It's possible. I don't know. YouTube, please do not tag this with a COVID-19 misinformation flag, because I am saying absolutely nothing in this. I'm just saying I've spent time reading papers and stuff like that, trying to figure out if vitamin D helps protect against COVID or not. And I don't know. It's not certain. The science is not settled, right? And so we're here in the moment in a pandemic, having to choose whether or not we're going to take vitamin D. And so whenever you're a critical thinker, you always have to think about things in terms of pros and cons and weighing the pros and cons. And this is something that it's a subtlety that is missed on a lot of people on the internet, right? Like, you know, like I can do it for, like, I've taken philosophy. I can do it for basically anyone. It's like I can do pros and cons for Stalin, you know, one of the most evil guys on the planet, right? Like, pro, you know, he fought Hitler, okay? You know, pro, he helped preserve the art, you know, in the Hermitage or something, right? Does that outweigh all the cons? Hell no. You know what I mean? Like, you know, but people think, like, if you say anything good about a horrible person, you must like them, right? And if you say anything bad about a good person, you must hate them. And that's that all and nothing fallacy that I talked about. It's very, very common where people don't have that sense of nuance of, like, being able to weigh the good and bad, because, spoiler alert, most people aren't 100% good or 100% bad. You know, Stalin was pretty close to it. Like, when his son shot himself and didn't die, Stalin said, my son is so incompetent, he can't even shoot straight. Right? So, like, the hell, dude? What the hell? your son just tried killing himself and you mock him. Like, what the hell, dude? Like, damn, you know, like that is not cool, dude. That is not cool. Right, but like people, sounds like when you agree with an national by a political party, people assume you're a part of that party. Yeah, or you have to agree with everything they do, right? You know, there's this whole lecture I can give on labels and how kind of labels make you dumb. Because if you identify as a Republican, then it will predispose you to liking things that Republicans say and predisposing you to not liking things Democrats say. Like, it's that in-group effect that we talked about before. Like, even when the in-group makes no sense whatsoever, like you're just put in a group with somebody, people will act preferentially towards them. And they'll tend to believe things good about people that are in their group, and they'll tend to believe things bad about people in the opposing group. It's just a thing. So if you can reject labels, then, you know, it'll make you a little bit less susceptible to that bias. Okay, so anyway, so coming back to this, you know, when weighing a decision in the moment, you have to look at the pros and cons, right? And for me, I was like, well, vitamin D supplements are really cheap. You know, it is a con. Like, there is cost. Like, the con to taking vitamin D supplements is there is a cost. It's, I don't know, not very much. Maybe it's because I'm a baller, but it's like you can buy like a giant bottle of vitamin D for like $5. It's not too bad. Another con would be there's a small chance of vitamin D overdosing. You know, like you have to take a lot of vitamin D to suffer an overdose from it. So that's kind of a minor con. And the pros are like it may help against COVID-19, and people that are vitamin D deficient, which is, you know, wintertime and indoors, people tend to suffer vitamin D deficiencies. You know, the pro would be like even if it doesn't help against COVID, and like, you know, if you need the vitamin D, it might be a good idea to take it. Okay. So, is it possible to OD on vitamin D? Not like, okay, I'm not a doctor, right? But from the research on it, like you have to take this massive amount of vitamin D. Right, like way more than like what you're going to be taking in a supplement. Like the it's a rare but potentially serious condition. Taking 60,000 IUs a day for several months. Okay, that is 100 times. That is 100 times the recommended dosage, right? A day. 100 times the recommended dosage a day, 4 months, right? So, yeah. Again, I'm not a doctor. Do not consider anything I say as medical advice. I'm just telling you what I've seen from my internet research, and I therefore consider myself an expert on it. Right? So, you know. And so I took vitamin D to give you the answer. It's like I weighed the options, and I'm like, yeah, all right. You know, it's got possibly a good upside. Downside doesn't seem to be too significant. Hell, I'll take it. You know, and maybe a year from now, after the research is in, we'll learn that vitamin D did absolutely nothing, and I'm okay with that. You know, like I'm okay being wrong, and that's also part of critical thinking. Is like, you know, yeah. If you're so petrified, if you're so terrified of being wrong, you'll never make any decisions. But not making a decision is a decision, right? Like, I won't take the vitamin D until I know for sure. You know, like, that's a decision. You've just chosen no instead of yes. You know what I mean? So, I was given vitamin D2 pills. Now you're hesitant to take them. Okay, so what was that? 60,000 a day. 60,000 IUs a day. Was it? Yeah, so like if you've been given vitamin D supplements, yeah, these are like 5,000 IUs, so it's like you know, 12 times below the overdose level, right? A lot of them are 2,000, and so that's like 30 times below the overdose level, you know, if that is, you know. So these are 10,000. Yeah. So consult with your doctor. Don't believe your professor, who's a computer science professor, not a pharmacy professor. Okay. So, all right. So basically, the Thomas Kuhn was this guy who wrote a book called The Structure of Scientific Revolutions. Okay? And so basically what he says is the way that science works isn't this sort of linear progression forward. Rather, there's false starts, there's things that look like a correct theory that turn out not to be, and there's backtracking and blind alleys and all this kind of stuff. But basically, overall, there's a paradigm that we're operating in. So, sunny delight. So there's a paradigm that we're operating under, right? So we had Newtonian physics, right? Newtonian physics made by Isaac Newton. And then Einstein came along, introduced relativity, and immediately everybody thought that Einstein was correct, and they discarded their old textbooks and wrote new ones, right? Is that how it happened? You know, people immediately, it was just like, oh, Einstein's correct. His name is Einstein. They wouldn't have named him Einstein if he wasn't an Einstein, right? No, right? Like, just because a dude in a patent office comes up with a new theory doesn't mean that it's right. You know, some guy's cracked. Yeah, and so just because it sounds good doesn't mean it's right either. And so every time there's a new big idea in science, there's resistance to the idea. And so there's a struggle between these different paradigms. There's a struggle between Newtonian physics and Einstein, relativity. And, they sailed a boat out to the South Pacific to observe a solar eclipse. They could view light bending around gravitational lensing, And they're like, oh, look, Einstein was right, And so basically what happens is you have evidence for a theory, against the theory, for the other theory, against the other theory. What happens is that when one theory, just the evidence just mounts up so high you can't ignore it anymore, then there's what's called a paradigm shift, right? So there's a paradigm shift. And a paradigm shift means science goes from one consensus view. Remember how we talked about consensus theory of truth and how this would come up, the different theories of truth come up all throughout the semester. So science has a consensus view of what's right. And basically when enough anomalies occur, anomalies are things that don't work in the current paradigm, then and a better theory comes up that matches the data better, then there's a paradigm shift. And so, going from geocentrism to heliocentrism, and then heliocentrism to relativity, because like heliocentrism based on Galileo is based on an unmoving sun, right? An unmoving sun with perfectly spherical orbits of the planets around them. Like, when people say that Galileo was right, he wasn't right. Like, arguably he was more right than an unmoving Earth. Although under relativity, I guess you can set either of those to be the, frame of reference. Maybe neither of them are right, or I don't know, both are right. I don't know, but basically you got Galileo out there, and he's like observing the moons of Jupiter, and he's like proposing this Copernican view, because he didn't really invent it. Copernicus kind of did, and he invites the Pope out. And the Pope looks through the telescope. He's like, oh, that's really cool. You should write a paper on it. And then, like, do you guys know who got mad at Galileo? It wasn't the Catholic Church that got mad at Galileo originally. It was other scientists. It was a struggle. It was you had this theory of how the heavens worked, and it worked okay. It had some problems with it, like the retrograde motion of Mercury, where it appeared to go backwards. That's a problem, for geocentrism. Less of a problem for heliocentrism, right? Because you have a planet going like this and a planet going like this, and sometimes it'll appear to move backwards. And so the geocentric view better explained the data than the heliocentric view. Sorry, other way around. The heliocentric view explained the data better than the geocentric view. But that doesn't mean everyone's like, oh, Galileo, Copernicus, you're so correct. Boom. We're just going to abandon 1,500 years of science. No. Does not happen that way. Does not happen that way. What happened was a bunch of scientists got mad at Galileo, and they wrote to the Catholic Church saying, hey, man, could you adjudicate this matter for us, basically? And this Galileo guy is spreading things contrary to the Bible. And so there were actually two trials of Galileo. Most people don't know that. There were two trials of Galileo. In the first trial, you had scientists versus scientists. You had the geocentric scientists, because Galileo was kind of an asshole, right? Like, he was kind of a dick, right? And he had this amazing ability to just piss off people. And Copernicus didn't anger people. Like, Copernicus, who published this heliocentric view of the universe, nobody hated Copernicus. Like, he dedicated the book to the I think a bishop or the Catholic Church or something, and the Catholic Church liked it, and they're like, cool, neat. Galileo had this unique ability to just anger everybody, and we probably know people like this, like brilliant people that just have complete lack of social skills, right? And so Galileo angered his fellow scientists, and he insult them like publicly and things like that. And so his fellow scientists took him to court basically over it. I'm not exactly sure how or why the Catholic Church should be judging a scientific matter, but that's what happened. And because the other scientists said there's a theological dimension to it. And what the Catholic Church said was that the science is not settled. There's good reasons to believe Galileo. Like, you can see moons around Jupiter going around it, so and you can see the shadow of the Earth and all this other stuff. Retrograde motion, good reasons to believe Galileo, but the objections presented by the scientists, the other scientists, the geocentric scientists, they were actually good objections. For example, if the Earth is moving around the sun, we should see the stars move, right? Because if you think about it, if the stars are just other stars in outer space, and the Earth is moving, you would see parallax, right? Like, when you're driving down the road, things that are close to you move quickly, things that are far away don't move quickly. And so if the Earth was moving, you would see a parallax effect. As it turns out, there is a parallax effect. It was just too small to detect. And so, point, for the geocentrics. And another point for the geocentrics were that if we're moving, we would experience motion, and if the Earth is spinning, we would, like if you spin something on a ball, like, things fly off of it, right? And so, in the tides also. And so Galileo forged tidal data because he didn't know about gravity. And so rather than admitting that there was a hole, there was an anomaly in his theory, he just forged tidal data. He said there's one tide a day, which everybody knows to be false. All you have to do is go down to the ocean and see that there are two tides a day, right? And he forged a day, saying, no, there's only one tide a day. And there was an argument about, if the Earth is spinning, is water sloshing around in the Mediterranean like a giant bathtub, and according to Galileo's theory, there'd be one tide a day due to the spinning of the Earth. And so he just forged the data, right? And so, like, all these people who think Galileo is the best scientist ever, nah, he was a kind of an asshole, and in a real way. And he also forged data in order to, because he really loved his theory, and so he forged data to support his theory instead of basing his theory on the data. And he just couldn't accept there were any anomalies. He also couldn't accept that orbits could be elliptical, right? Which they are. Kepler, who was either a contemporary or a little bit after Galileo, came up with the ellipse shape for orbits. Galileo's like, no, man, orbits have to be perfectly spherical. So, there were problems with his theory. And so, nah. Yeah, that's all he's doing. He's like, nah, I'm just not gonna even pay attention to these anomalies. And so there was this trial basically on the science, and the people who objected to Galileo were like, look, here are these problems with geocentrism. And so the Catholic Church ruled this. They said, Galileo, you can continue researching heliocentrism, but you can't state that it's settled science, because it's not. And that was it. That was all the Catholic Church did. And then 20 years later, Galileo wrote a book called on the. It's got a long name, but basically it's on the two systems, heliocentrism and geocentrism. And he made the mistake of calling the Pope an idiot. So the Pope, who had been his friend, and had like supported his research, the Pope was called an idiot, a simpleton, simplicico, and simplicico in the dialogue on the two systems was parroting the words of the Pope. And Galileo says, "Oh, I didn't intend to call the Pope an idiot. It's just a name, simplicico, idiot." And whether or not that's true, I don't know. But basically, the Pope's like, "Oh, screw this guy in particular," and Galileo treated heliocentrism as settled science in violation of the court order from 20 years prior, and that's why he was sentenced to house arrest at his second trial for violating the terms of the first trial. And so for 20 years, he'd been able to publish papers on it and stuff like that. It was when he really was for pissing off the Pope, who was his patron, Berberini, that he really got in trouble. But anyway, the point is that when you have science, it's messy, and people get angry, when your favorite theory doesn't get supported by the evidence, you search for more evidence for your side, and there's a lot of areas like that in science. You might think, well, this is just a once every 500 years thing, no. Like, go to any scientific field, and there's going to be very serious debates about something that people get upset about. Do you have a textbook reading this week? Yeah, I'll post something. And so, there's this phrase that science advances one funeral at a time, because it's not like people change their mind; it's just they die. There's this notion that scientists will sort of like follow the evidence where it will go, and there's a certain amount of truth to that. When people aren't emotionally invested in something, like they change their minds easier. But like if you look at the Big Bang Theory is called the Big Bang Theory because that was a mocking term for the theory. Like it's just a Big Bang, man. And so there were scientists who believed in a steady state universe, in other words, an eternal universe, rather than a universe that had a beginning. This is not long ago, you're talking about 60 years ago. And it depends on their openness, yeah. But also, like, if you've published a bunch of papers on the steady state universe, you're emotionally invested in it being correct. And so every time more evidence came out for the Big Bang, like they found the cosmic background radiation really did have strong evidence for the Big Bang. The people in steady state theory would publish papers saying, well, it doesn't really mean that, and they're looking, and to a certain degree that's healthy, because somebody says, look, we've found evidence in the cosmic microwave background radiation that the Big Bang's right, and then you want people to oppose it, right? But for about 5 years, there was this big fight in the 1960s. There was this big fight between
AT&T's in the front with service requests. They say you asked for them to come.
Yeah, they should be fixing the internet again.
No, there are two girls now.
Yeah, they're probably going to do a dig. They're going to do a permanent repair. So guys, my internet is probably about to go out because they're here to do a more permanent repair on my internet line. So we'll just call it here. Okay. So, long story short, science is messy. There's a struggle, and eventually a new consensus emerges. Okay? So, there you go. We'll pick it up. We'll pick it up on Friday. Do we have another midterm? Yeah, the midterm will be next Friday. Okay. All right. See you guys. The internet's about to go down, so we'll just